need yet. Okay, so how do prisms fit in the hierarchy? So we've learned about, what have we learned about? All kinds of stuff. So we learned about basic optics, lenses, some of the operators, and then this is sort of in the bulk of this is like folds, traversal. This was indexable structures, and now we're on to prisms, which I don't know really anything about. So interesting category of optics, so that's fun. They behave similarly to traversals. However, prisms can only focus at most one value. Since at most one technically fits into 0 or more, all prisms are valid traversals. Prisms have a, hang on, I gotta shut my door. I don't want you to hear my girlfriend private business, nor it's also kind of distracting. Hey everybody, there's a whole bunch of people watching it. Okay, so prisms have a secret weapon which traversals don't. Prisms can be run backwards, taking a focus and embedding it into a structure. Taking a focus and embedding it into a structure. Interesting. We'll see throughout this chapter how prisms are a natural candidate for specifying pattern matching semantics and help to work with some types as well. Okay, that's kind of interesting. Um, One could describe traversals. Oh, well, I guess maybe I should read these. Um, well, I don't really know what embed means yet. So, yeah, that's kind of the. Oh, okay, I misunderstood this. It's 0 or 1. At most, one value. At most. Okay, that's kind of interesting. So simple pattern matching prisms. Each prism represents a possible pattern. Um, okay, so we have an either type. Yes, good, good. By convention, prisms which match on the constructor of a value are named by adding a underscore to the name of the constructor they match on. For the either type, we have underscore left and underscore right prisms. Cool. Okay, so the way I typically work through this book is I just start with the letter A and I just put stuff in here. So that's kind of how it works. Okay, so 0 or 1 means we're probably going to use this a lot. So I guess this is going to give me, and then we'll, down here, we'll just open up GCI. I kept writing CHI a bunch today, so it's kind of weird. I don't exactly know why. Drew Cooper, hey, hello. I think I finished the semester with a 4.0, hopefully. Nice. My stats for engineer class was nice. Uh, nice. Very good. Cool. Congrats. That's really good. Uh, just message and nothing. Okay, that's cool. Um, so I guess we can like I don't know that left and right are maybe the most useful um like from a standpoint, but okay, these obviously track based on this. Um okay, so since prisms are valid traversals, we can set update or traverse the focused value through them. All right, so if it was a left, we'd update it, otherwise we'd get nothing, or we could reverse it using over. Cool. Cool. Um that's interesting. I don't know that I mean I've definitely caught people cheating as a TA. Just gave them zeros typically. Ooh. Okay, so maybe or nothing prism. This makes a lot of sense here that the nothing prism would point at unit, I think, based on the set traversals that we looked at previously. Yeah, so this is awkward, but I don't see how you would do that in a different way. And I guess you couldn't have, like, you can't really have a nothing and an over unless it's just const unit, I would guess. So I would guess that nothing at nothing over uh well, anything but const unit. This should compile, I think. What? Oh, am I supposed to do this like that? No, I guess we can't really do what I was thinking about. So this compiles, but it just gives us nothing. Why does it give a nothing? I don't understand why this gives us nothing. Oh, never mind. I do understand. The weird part is that it compiles. Although, can I like put like a number in here? Const one? Like, does this still compile? No, I didn't think so. Okay, so this compiles, but it's sort of weird. Doesn't do anything. But that's kind of cool. Okay, so if you want a quick way to simply check whether a pattern matches, we can use the following combinators: has or isn't. I always like when there's functions like this, because you can actually write is not um, as the contraction. Um, there's also an is to match isn't, but that's hidden away in control lens extra to avoid naming conflicts. So usually it's more convenient. Has. Has checks whether the given fold yields any elements when run. Oh, I wanted to write a note about this. So this compiles, but it is awkward. Okay. And so we could have has, right, left, message, false. So it does not has right, which is funny to see. Okay, so has it's a yeah, okay, it's a pattern match. Did we get a left or a right? Then I guess you could view them like, or do something else. Sorry, so there we go. Um so this is kind of interesting. Um isn't nothing just one. All right, so D should be false and E should be true. Isn't nothing. Weird to say. Okay. Jetting prisms with make prisms. So here's a laughably simplified representation of HTTP web requests as a sum type. Sure. I'm not going to write these type synonyms. I just don't think it's that important. Although maybe we're going to use it later on. because these prisms will just be on strings anyway, so you could just build whatever you wanted. I suppose we could make new types, and then we also have lenses. That could be fun to play around with. So we'll make a body. And then we need template Haskell. And we will, what's the function? Make lens? Make lenses. Path. Make lenses. Body? Okay, so now we have path and body lenses, I guess, will be useful. I'm not entirely sure yet, but okay, so now we'll have like a request, which will be a post path body or a get path or a delete path derive show. Okay, so because we want to derive show on these, those all also need driving show, obviously. And then, cool. So that's this. And then we will have a make prisms function for request. And we'll see if it works. For anyone who's never seen this double tick syntax, it's a template Haskell thing. To be honest, I don't even know what it does. It try to? No, it doesn't. So I think it's just syntax. Like it doesn't mean anything. Well, it means something to template Haskell, but like it's not like a function. I don't. It's just syntax. Weird syntax, but it is. I guess that's really cool that it kind of shows the prisms that I made. Shows the prisms that I made. Right, we get some of it anyway. Post, get, and delete. We don't get the other prisms. Import control lens. Do I have to write browse? What's my prisms? Oh, my prisms must be. I have no idea what my prisms. Not really sure. But anyway, the point is, we get some prisms that allow us to work with this stuff. Request. Yeah, these look a little different than the other one. So it's like a prism, request, path body, some type, which is, or a product, then path by itself, path by itself. Okay, cool. So, each prism pattern matches on a single constructor and focuses all the fields that constructor contains. The make prisms combinator is smart enough to pack up multiple fields into a tuple for us. So we did E. So if we do F, we can do a get path users and then we get think this compiles. Looks like it does, but I don't know what it's going to do. All right, so we just get just path users, right? So what we could do is also, I think, view the path, view the what is the lens that's made here? Is it path? Oh, I think that what we really want is oops. And then we should get path. Oh, maybe we also need to go through just Oh, no, we would have to wait, how are we gonna do this? We can't say no instance for monoid. Why would path need to be a monoid? I'm not 100% sure. How do we reach further in? Maybe we'll learn that. Do we know this? Not sure. What is this? Oh, this is like append with. Okay. Anyway, these all make sense to me. They're pretty simple actually. Oh, maybe I'm supposed to do that. So get just path. Nope. We tried. Get. Okay. We'll keep going. Maybe it will make more. Okay, so review. Even though viewing through a prism may fail, uh, if the pattern match doesn't match, embedding a value into a pattern using a prism always succeeds. To run a prism backwards, we use the review action, um, which you can think of as short for reverse view. It embeds the focus onto the prism's pattern. embeds the focus on this pattern. B T. Okay. For example, oh, okay. It's kind of like making making a thing, but you could probably do this in a much more complicated. Maybe this one will allow us to write um, get. Oh, but we would need prisms. Does this compile? Oh, cool. Okay, that I sort of wasn't expecting that to work. Oh, maybe I don't need just up there. I just need path. And then we can F. Yeah, perfect. So, yeah. Okay, I misunderstood because I was thinking that we need the just, but all we need to actually do is compose the lenses. Not there's no just in between get and path. Um it either worked or it didn't, which is why we have the view maybe focus or whatever it's called. I think this is view, but maybe view. All right. So we can build a post from a get. We can build a post from a delete, sure. And we can build a post from a path and a body. Oh, this one could be cool. So I think that it will end up looking like post sharp. And then we need path. Sorry, path sharp sharp. Da, da, da. And then body like so. Well, actually, we can just do this because it doesn't actually matter. One of them's inside of a list and one of them's not. So yeah, this looks like it compiles. So we can just run that and we'll get back this. That's kind of neat. I wasn't really expecting this to kind of just work the way it does, but it's kind of cool. Okay. Um, yeah. What are you complaining? Sure, we can construct errors or actual values or embed things together. Sure. I'm sort of hoping that there's going to be like a really cool use for this that I don't understand yet. Because this all seems kind of straightforward right now. Oh, although most of the prisms you'll encounter will be used for matching on data type constructors, prisms can also encode more complex and abstract patterns. Cons is a more abstract prism, which pattern matches on the first element of a list-like type. Uses type class to do so. I've also included the specialized signatures. Or sorry, a few structures. So we can make. So if I had to guess, we can do cons 1, 2, 3. Oh wait, we need to actually build it. There we go. So we can't write just cons and then the thing, right? We actually need to use this review to materialize a view of a list. And I think that this will Yeah, it will just be a list because I guess this type right here is how it figures that out. Um, that's the thing that determines. Yeah. But we wouldn't be able to do more than a tuple like this. You couldn't like have another comma here. I don't think this would do anything. It would probably fail even. Yes. Because you can't make a list like structure from that. You would have to make like a tree, I guess, something like this. So I think will work, and it will just give us a list. Yeah. So I mean, this is the one of the weirdest ways to produce a list with 1, 2, and 3 in it. Can chat come up with a better example of what's the weirdest way to construct a list? The list 1, 2, 3 in Haskell. I should clarify, I suppose. So yeah, this cons behaves like what is that function called? Un cons behaves like what is that function called? Uncons, right? Isn't that how uncons works? My idea anyway. It's well, it's yeah, I mean it behaves exactly like uncons because we have this. What happens if you just try to ignore the what if we do 1, 2, 3 and then view cons? We might not be able to. Okay, let's make this an integer. I don't know what it's trying to do here. It seems like it's trying to combine them together. So what if we like try to make that happen? So sum comes from 3. I'm just trying to see like what's gonna happen. Oh, maybe we need to actually put this in parentheses. Oh, okay. So does it return these things sum together? What do we think? In a what is the monoid restriction for? That probably has something to do with the laws that I don't understand yet. Well, like if we give this thing an empty list, what does it do? Um, is it just gonna fail? So this will be some integer. Sorry, list of some integer because we need a monoid. So what does this do? Sorry. Oh, that's why it needs monoid. Okay, that makes a lot of sense. Because there's no way to materialize if there's um no list. So it uses mempty basically. That's why you need monoid. That's cool. I sort of wasn't expecting that. Um, but neat. I like when we discover stuff like this. All right, cool. So we did this, so that's like uncons again. Um this this would work if we just did Oh, there is no monoid car. Okay, never mind. You can't make them. You can make. It would have to be a string of strings for that to work. The string has monoid. I think. Yeah, it would because the empty element is just an empty thing. But there's no empty character, I guess. Okay, so we can uncons text or byte strings. Uh, what is this saying? So we're going to cons to reverse. So we're flipping the the list portion of the uncons. Okay, cons is a prism, so we can run it backwards using review, aka sharp, or octothorpe, whatever you want to call it, to cons an element into the front of a list-like type. This operation will never fail. So cons have freedom 65 BC ABC, cool. Um, if all we want to do is access the head or tail safely, the control lens cons module provides these traversals as head and tail. Oh, cool. So let's get those. That's kind of neat. So import control lens cons L. Hello. A head set J Jello. Jello. I don't really like Jello. Do you have any opinions on Jello? Okay. Um, Note that head and tail are only traversals and not prisms because there's no way for us to run them in reverse like we can with cons. Cherry Jello the best? If I had to pick one, which one would it be? I really don't know. I mean, like the only time I ever had Jello in probably the past 10 years was in Jello shots. It's obviously not like a good way to have Jello. That's true. Pretzel Jello is a thing. My family does really like pretzel Jello, but I don't. I don't like the Jello part. Like I would rather just have pretzels. Kind of want to go get some pretzels right now. I forgot about pretzel Jello. I don't know if that's like a. Is that a thing for like Americans? Like where does pretzel Jello come from? Like who decided this was a good idea? Because it's such a weird thing to eat. Well, I guess yeah, this is what I'm thinking of, right? Pretty sure that's. Is it a Pittsburgh thing? I don't think so. I see Pittsburgh down here. Pretzel salad? I don't know what pretzel salad is. Okay, anyway, we're getting we're getting off track. Okay. So since there's no interesting information in an empty container, it simply matches the unit type for similar reasons of nothing, I suppose. Um, so usually only useful to use this with predicates like has or isn't. We could say isn't empty or has empty, which is such a confusing thing to say. Um, isn't empty is easier, I guess. Mm. So cons represents. Well, I don't. I still don't know why we need these. It's not obvious to me. Okay. So we'll look at one last abstract prism show. Um, as implied by the constraints, this prism can read or show values to and from their string representations. The pattern we're matching on, whether the value can be parsed into the result type. Okay, so we can like materialize anything as a string, and we can um, show maybe integer. Neat. That's pretty weird. Um, let's stick these in here. I don't actually know why I wrote them down there. Because I would like to keep them. Neat. Okay, so I strongly recommend using an actual parsing library for any production use cases, but it can be handy for quick dirty parsing. Sure, so 12 int. We tried to show a boolean, it wouldn't work. I tried to turn it to an int, wouldn't work. That's kind of interesting. Can't copy and paste. That's like a very interesting function, I feel. Like just go pick out anything that's a number. I don't know what like I haven't really thought about parsec or well, actually I've thought about it, but I haven't done mega parsec or anything like that recently. So I don't know if like how much code would it require to rip out all of the numbers in a sentence, for example. I feel like it would be a lot more work than that. Although I guess you'd need to compile a lens, which is quite a bit of work. Although those parsing libraries um, are not simple to parse either. Okay, so we'll learn some more Prism specific combinators soon. Cool. All right, so exercises. This is our favorite part. Which prisms will be generated from the following data declaration? Okay. I'm not gonna do their types because that's like a classic thing that I always get. I mean, I guess I can just look it up. It's not a big deal. Um, string, telephone, int, address. Can't spell. The freaking phone is blowing up, yo. What are you doing? Why don't that autocomplete? Those count as characters that it should autocomplete? That's kind of interesting. Okay, so it's gonna make email. It's gonna make telephone. It's gonna make address. And their types are going to be something. But I'm gonna have to look this up because I don't remember. Okay, so it's going to be Prism. Oops. Bad. Prism from string to string. right? Specifically the cons. Okay. So this goes from request. Oh, okay, okay. This is not the second one's string, but the first one's contact info. Yeah, that makes sense. So this is contact info, or sorry, Prism prime contact info int, and then this one's Prism prime contact info string string string. Yeah, that makes sense. Hopefully, as usual, if anyone has any, we did that. Two. Uh, Fill in the blanks. I always do that. Then I'm like, I don't actually want to write that. P. Write 35 at underscore plus set 5. The result should be right 40. So this will just be right. Um, we're not gonna copy this whole thing. Well, I guess we. Well, no, we can just capture this. That's probably enough. And then folded underscore a. Result is mind hour. Okay, so this symbol here means to list of, and then folded means focus on the elements, and then focus on the justs, I guess. Let's check these. Wait, just colon does this? That's cool. I didn't know that. Anybody else know that? Maybe I haven't really thought about it before, or just haven't accidentally done it before. Okay, so there's P, there's Q. That makes sense. Um, R. Hello. I mean, this is just the same thing, basically. Oh, it's not. Yes, yeah, it is. Same thing. Um, at just stone throne. I wrote. I think that's a word. Um, power stone. I don't know what this. Oh, okay. This isn't. Oh, this is probably folded. Traversed. I think either way it works, but so cool. S this loop loop. Yeah, so we're trying to invert the true, I guess. So it ends up being right, false. Eureka. Okay, so first we need left, then we need 1. Then we need right. Think that works? Yes. Right. False. Yeah, that one's a little bit contrived for sure. Or it looks contrived anyway. I can't imagine somebody. This just ends up being um sharp. Well, we could also write review. That would work as well. So I kind of like writing it in a different way this time, just to mix it up a little bit. Okay. Stand up as well. Ooh, nice. Okay, then we gotta lift this up just a tiny, tiny bit. Let me know if you have any issues hearing me anymore. You. All right. RSTU. I'm tired. Isn't show not an int? Okay, so we're trying to parse an int. Yeah, I mean, I guess this is just int, right? Market. The heck is a market? Oh, uh, prism string prime. Sorry, I forgot about the prism part. I was just like, yeah, of course, that's right. It's not right. This was supposed to print true, and this was supposed to print do re mi. Okay. Write an expression to get the following input. Just 1, nothing. Just 3. Output 1, 3. I don't really want to write like a check that this is true or something. I just want to do it. Excuse me. So this becomes input at no folded just oh each. Sorry, I just realized it was a tuple, not a list. So if it was a list, you would use folded, I guess. But it's a tuple, so we need each. Um, I guess this is fine. Like I don't really. We can just check it. But like I would like to keep the output there somehow, so we could do that. This is fine. Um, right, like this is just for me, so it's not really meant for anyone else. The nice thing about the let blocks is we can have the same inputs. output. X, Z, Y. So this is just cons sharp input. Oh, we need a reverse. Okay, so first we reverse oh wait, we could also oh wait, no, we can't do that. Because we can't cons and then reverse, I don't think. Not easily anyway. Oh, yes we can. Um we can use tail. So we can say at underscore tail over reverse. And I think this works as well. I was just trying to avoid the parentheses if possible. Maybe this is less readable, but was it readable in the first place? Probably not. I mean, some people can read these, I'm sure. Jappy Jappy can read these. Can you help me with hiding some stuff in JavaScript? What do you mean hiding some stuff? Like you want to hide like a div or something? I think there's like a display style element that you can set to none and then they go away. Is that what you're asking? Yeah. So I think that there is CSS display none or something. Yeah, let me find something. Yeah, I think it's like this. So, yeah, there might be a hidden as well. But again, I don't use it. I don't do a ton of CSS, so I'm just guessing. But I think that if you did something like this, it would hide the thing. Visibility. So there you go. Also, hey, vitamin overdose. Um, I know that you're all of these. Your name's not in there. But hello, how are you? You'll have to tell me on Slack, I guess. Then I won't forget, I promise. Good. Uh, don't believe that. Oh no, that's not what I wanted to do. Why stop? Don't do that. Silly thing. Wheel of Fortune. Okay, so trying to hide the two animations at the beginning. What does that mean? Hide. I don't fully understand what you mean. These. You want these to start as hidden? So I guess you would do CS. Wait, no, style equals visibility hidden like this. Like that? Is that what you mean? And then you could wait a second and then change the visibility, I suppose. I'm not exactly sure what your sentence means, but I think it's something like this. So I guess that after some time you would have to change the style. It I don't know a ton about JavaScript, so we could do. You're asking me to go way out of my element. I is there something in here where you wait a little bit? Also, I don't think that this does anything. I don't think you can do this. Um, uh, flip CSS setting from JavaScript. I honestly I don't know. I'm just like no, I don't want to. No, let's change changing CSS. Oh, so I don't think this is an ID. Gosh, what are these called? ID HTML. I don't know. Okay, yeah, you can just literally use it. I'm overthinking things, which is not surprising. That's kind of what I do. Um, so ID equals the, and then we could say the style visibility equals uh something else. Is it was that just a true or false? Um, CSS visibility, something like there you go, visible. Yep. So basically, we're setting it, but then completely undoing it. I think there's also like there's got to be like a get elements or something. Get elements by class JavaScript or something. Yeah. So you could use this, get all of them, and then loop over the ones that you want to switch. You could also like put a time gap in between them. So it would be like I don't know. Go back to this. Yeah, I just used ID here, but you're using class word, for example. So I think you could also do like get elements by class ID and then or by class name, I guess, and then loop over them, for example. Yeah. I would try the loop thing. That probably would be more efficient. So anyway, welcome to my JavaScript stream. I've actually never I don't think I've done any HTML or JavaScript on the stream actually. Um I guess I've written like Shakespeare or what is it called? Hamlet. Does that count? It's kind of like HTML. And I've also written the Julius or whatever the other one's called. I don't remember. Anyway, so we're on X. It's so funny to write in other languages now. They look so weird. Like I don't know. It's just weird. I very much like writing Haskell. Okay. So what are we doing here? So oh, this is I think easy. Left, just, right, materialize, input. X. Left, just, right, do the hokey pokey. Okay. Easy. Easy. All right. Writing custom prisms. So this was kind of a weird section, I feel like. I feel like it was, I don't know, like I don't obviously see from 9.1 why prisms are cool yet. Does that make sense? Um, yeah, so I'm hopeful we get some more interesting things to understand how to make prisms cooler. All right, so so far we've seen how we can generate prisms for matching constructors of data types using make prisms, but sometimes we want to match on more abstract patterns. We can build a prism for any pattern, which we can reverse. We can imagine our prism as refracting your data, splitting it up and focusing only on the pieces which match the pattern, dissipating the rest. Luckily, the lens library provides us with some helpers to make constructing prisms easy and foolproof. Okay, we have a prism and a prism prime, uh, one of which allows us to use. Okay, so we're doing either A or B, or we can have the same structure and it can be a maybe. Well, sorry, it's the same input and output structure. Yeah, these are the structures and these are the focuses. All right, so both functions take two arguments, an embedding function and a matching function. So embed. The embedding function is where you specify how to reverse your pattern match by embedding the prism's focus back into the pattern. This is the function which will be called when reviewing and must never fail. Okay, so let's see if we can just write one of these without having to um, like do whatever. So we're gonna say like data A equals A because we just need something to work with. And then we're gonna say A is a prism from, well, these need to have, so we'll just put a string here. So T is the thing we need to construct, which is an A, and the thing we need to make it is a string. So A will be a prism. A will be our embedding function, which should always succeed. Our matching function is what? What is our matching function? So given a structure, okay, so it's just like A S just S. Oh, sorry. Right. So I guess this is our prism. So yeah, like if obviously if A had more, actually let's make A with more constructors so it makes more sense. Um, And then here we could say case AS goes to right S, BS goes to left. Either the left is the structure itself, so left B will it automatically tell me? Nice. Okay, cool. So does this compile? It seems to. Okay, so our A prism basically will just embed the T structure as left. And yeah, this makes sense to me. Um, any questions here? People okay? I think it makes sense. We could also use prism prime, and then this just becomes underscore nothing, and this becomes just, which are both totally fine, I guess. Okay, so rebuilding just and nothing. Better understand. Oh, I guess I should write the other one. So wait, what's the difference here? Like if I write prism prime just and then uh nothing, ignore this. Hey Pedro. If we had a third, yeah, if we had a third constructor, like this is probably arguably better. But if we, okay, so let's go back to the prism case, right? And the way I have this, sorry, right, and then left B. So if we add C string, oh yeah, yep, okay, sorry. Maybe I was just like, yeah. In this case, we're only writing the prism for A, so we don't really care that much. But I do kind of want to simplify this because I don't see the point in using either if I don't need to here. Oops, wrong button. Oh well, nothing. And this has to be prism prime, like so. And then we could obviously write a prism for B if we wanted to. But they are generated for us with the make prisms function, which Pedro, you wouldn't have seen yet. So like if we just use this make prisms template Haskell function, it would just generate those lenses for us. Sorry, prisms for us. So we wouldn't really even have to do this. It's just kind of learning. All right, to better understand how this all works, we'll rebuild the prisms, rebuild the maybe prisms just and nothing from scratch using Prism. Okay, so I'll just do it. I'm not going to read the book. I don't think that this is actually that difficult. Okay, so the thing we're trying to build is a maybe. And I guess it's maybe A. And the thing that we'll have is an A if we want to construct one. So, oh, and I need a prime here because just is already defined. So this will be a prism of maybe A. We will match, whoops, this here. And if we have just A, that becomes just A. If we have nothing, that becomes nothing. I think. Oh, this should be prism prime too. Okay, let's see what we got here. Go to match expected type PAFA with actual type ABA2. All right, so we need an embedding function. Oh, I'm missing the embedding function. The embedding function is just, right? Oh, it's not. Okay. Sorry. I'm being silly. Why would you tell me that the Patriots are playing the Rams right now? Okay. And then So our embedding function is going to take an A and make a structure, which is maybe A, or just A. And then we need a pattern match where we take out the structure and return a maybe of that thing. So that's what we're doing, isn't it? Okay, couldn't. Maybe I can't use Prism Prime here. Oh, I needed. Okay. I actually think that that was okay. But what I need is Prism, and this should be right. Okay, maybe I'm wrong. Takes an A, takes the thing. Takes an S, returns a right A. Takes an S, returns a left E. Why would I need two justs? I don't understand why I would need two justs. Oh, you don't. Prism, just. You see it? That's supposed to be a dollar sign, not an ampersand. So that matters. And then also, I think that it was fine before. What is this? Tab character. Why would you use... What is... I'm so confused right now. What am I doing wrong? Also, why is it adding tabs? What is happening? It's 100% adding a tab here, but I don't understand why. Like, I didn't ask you to put tabs there. What was it doing? What did I do? I don't understand. Okay, anyway, so I just had a syntactical error there. So this would just be adjust, and this would be nothing. Yeah, so that makes sense. And I imagine that we can't just say I don't think we can just do this. I think the type needs to change. Oh, maybe not. Oh, right, because we're just using maybe A. We would have to do this if we wrote, this would fail, I think, if we did maybe B, AB, and then it will fail because of the type, and then we would need just there. Oh wait, yeah. How do we get a B out of this though? Match just A. Oh, it's a maybe B. That's the trick. I see. So you have to use Prism here, so you can have right and then left. That makes sense, I think. Turn a left of the new type. Yes. Yeah. Because that's the only way you could make a maybe B, right? We can't make a maybe B from anything else. We don't have any tools to make a maybe B. So the only thing that can ever be is nothing. Yeah, that makes sense. That was kind of fun. Um, implementation is quite simple. We'll start with the match function. I don't really all that carefully here. Do yeah, there's that point. Even when we fail to match, we still change types. The embed function is even easier. Okay, so for nothing, we can only ever have a unit here, which makes sense because there's no um excuse me, there's nothing to focus on. Yeah, this makes total sense to me. Great. Matching string prefixes. That sounds kind of interesting. Let's write a quick prism for matching different string prefixes. I like to match strings which start with a fixed prefix and ignore ones that don't. Okay, so prefix, string, prism, structure, and the focus are both a string. Um, Kind of surprised we're using strip prefix, but I don't exactly know what the shape of that function is. So let's go look at that real quick. Strip prefix. So okay, so we're just gonna get a nothing if it doesn't actually do the thing. The idea. Okay, so given a prefix, we will make a prism. Um, our embedding function, that makes sense. It needs to be um, like so, and then we can pattern match. Um, oh, right, it just needs to return a maybe, so the strip prefix function just works. So given a string, you can just, that makes sense. Prefix from S. You get a nothing back, so it should be fine. What is this complaining about? Okay. Sure. You can have rank-in types for that, I guess. Okay. So let's try and use this thing. So y. So if we tried to materialize this with like hello world, I guess we would get hello world, if I understand correctly. Perfect. So that's cool, I think. And then the next thing I want to do is say like hello world, potentially check out the prefix hello. And then this is going to return just of what? The whole thing or just the prefix? Or space world? Um, we need to return the interesting. We're gonna get just hello from this. No, we're gonna get we're gonna get space world inside of a just. That's what's gonna happen. Okay, makes sense to me. Yeah, so this makes a lot of sense. I was thinking we were gonna do something or need to do something a little more difficult, but strip prefix is great. Okay. Oh, and yeah, okay, I guess there's laws about how this must behave, so that makes sense. Um okay, so okay, here we go. So this is checking that you load HTTPS, for example. By new prisms using our existing one, we can say sure, secure is just prefix HTTPS, and we can append the account number only if the um the link is secure or whatever. Cool. Ooh, Fizzbuzz. Everyone's gonna have a comment about this. We'll look at one more slightly abstract use case for prisms in an attempt to get revenge against the reviewer or interviewer for asking us pointless whiteboard coding questions. We're going to implement our solution of Fizzbuzz using only prisms. Okay. If you, dear reader, are part of the 1% of folks who haven't heard of Fizzbuzz, although actually I've never done Fizzbuzz on a board before. Just to iterate through the 1 to 100. For each number, we're going to print Fizz. If the number is divisible by 3, Buzz if it's 5, Fizzbuzz if it's divisible by 3 and 5. All right, so since this is a single prism, we can use the simpler prism helper to build it. From the looks of the problem, we've only got one pattern we need to handle, whether a number is divisible by some other number. Okay. Not what I was really thinking about, but sure. Uh, okay, so the embedding function is just const factor, I think. And then if we get an n, and n is divisible. This is just n, otherwise nothing. This is supposed to be an arrow, which I always goof up when I write odd. Is there a factor function? I feel like there is. Maybe not. Factorial, factors, factorize. We basically want int bool. I'm not sure if this is a thing. Doesn't look like it, but this is fine. Okay. So this is a factor. Um, oh, okay. This kind of makes sense. So, okay, what's the logic here? So if it's divisible by n, we want to turn it divided by n. Div factor. So yeah, so the goal is like, what is the goal? I feel like my embedding function is wrong. It is wrong. It's supposed to be okay. So it's like, yeah, this makes more sense actually. With this embedding function, it makes more sense. So it's like if you were to materialize uh so factor 3 with 3, that would be 9. But if we try to 9 view, sorry, this factor 3, we get its factor. Yeah, I think that makes sense. To be honest, I was hoping for something more interesting. It's pretty cool, I guess, but I was hoping for something more wild, I guess. He's got Chris has some pretty wild examples in here, so that's why I was hoping. Um, not an is it possible? Is it possibles are the worst. Try to write a custom prism for matching on the tail of a list. Okay, so if we want to materialize a tail, we can only do it for something that's a monoid, right? Because we need some kind of mempty, I think. Right? Like if we want to write tail uh ABC, right? You need to be able to have a character that uh can be a mempty to act as your head, I think. Wait, no. I'm thinking about this wrong. We're not materializing a list. We're materializing a tail. I can't materialize a tail. Can I? Is materializing a tail just putting it in a like itself? I keep using the term materialize, so I apologize if that's a confusing term. Okay, whatever. Just like write something and see what happens. So we run a return to nothing. So we need an embedding function. And we need a matching function. So our embedding function will be take an A and make a list of A. Our matching function is going to take a list of A and return a maybe list of A. Right? Oh, okay. What does embed mean here? I feel like it's just const. Or sorry, id. Wrong function, me. But like that feels wrong. You know what I mean? Like it doesn't feel correct. Because we're not really materializing a tail. Although maybe we should just embed. Well, no, because the tail can fail. So like yeah, what I was thinking about doing is okay, take this and pull out its tail and then make it a new list, but you can't do that for an empty list. So I think embed is impossible to write correctly. I think you can write match okay, but you cannot write tail correctly. Right, this just becomes HTT, otherwise nothing. Oh, this is equals. See, I think that's why I write equals. Wait, then I write? Oh, just T. Could it match type? What? doing. What was I doing wrong before? Can you not pattern match inside of a guard block? I guess you can't by what I just saw, right? So we'll just use lambda case. I don't care. Um, or I could just yeah, okay. I'm adopting unison style. I've pretty much done that for a while now. So we'll just keep it at this. So this is wrong, I think, is the point. I think. Okay. Well, anyway, we'll leave this here. Um, so this is incorrect because you can't uh, embed the the tail of an empty list, and embed must succeed. I think that's right. 2. Implement cons. For lists. Sure. I think we can do this. Prism, list A, list B, list A, B, list B. Cons. So we'll have a prism with an embed function and a match function. So let's just get the types right first. So our embed function is going to take an A to an A, I think. Actually, it's probably B, but also we're going to need. We already have rankin types, so that's actually, yes, we also need scope type variables, I believe. So let's just get that. I don't think rankin types gives you scope type variables, but we need A and B to be the same each time. Okay, so undefined match is going to take a which one's which? So it's on the it's one or the other. And on prime. Could have matched type A. So are these supposed to be all A? Wait, no, that can't be right. I'm very confused. Okay, so the prism Why are you doing this to me? Just just leave this here, please. Is B to S. B to S. Wait, can I not use Prism Prime here? No, I can't. So that's first of all. And then, my bad. So this will be embed and um, match. All right, and then okay. So this should get us the types now. So that one's got to be B to B, which makes sense, I think. So this is S. Sorry, this is B, and this is T. B and T. And then match is going to take. Oops. A or S to left. Sorry. Yeah. Left T, right A. S. Um, A. Okay, cool. Sorry, it's a little tricky for me. I still have a really hard time with like converting the STAB in my head to where these things go in the functions. Um, I don't know. The types are just kind of hard. Probably doesn't help that I like stopped doing this for a month. Okay. Anyway, this one easy. Head, tail, head, tail. You probably can do something clever with um uncons here, or sorry, uncurry. I forget which way it goes, but I have a feeling that you can write dot uncurry. One or the other, I feel like. Yeah. Now, would you want to write this in real code? Probably not. I don't think so. It's this code is so trivial that I think it makes sense to write. It's just kind of a parlor trick that you recognize this as some uncurry or curry operation. And maybe it's even less impressive because I always get it wrong. All right. Case. So if we can get a head and a tail, then we can return those things here. If we get anything else, okay. So yeah, I mean, how would we get a list of B? The only way we could get a list of B is if it was empty, and so I think this is right. Man, I love lambda. Okay. Bonus. Implement cycles, which detects whether a list consists of exactly n repetitions of a pattern. Okay. Um. Okay. So, cycle. It's certainly a prism like this because, yeah, I mean, you just look at the examples, right? List of care, list of care. Um, um, okay. Cycles. So again, we need prism, bad match. For these more complicated ones, I kind of like doing the these separate. Um, okay, so this is going to take S. Ooh, that's fun. The other thing is this is going to be int. Embed, I think, will be relatively easy actually. It's match. It's a little trickier. Okay, so match is gonna take a list of A and return maybe list of A. And embed will just take some X's and duplicate it, which I think is just repeat n access. Uh, what functions are here? There's like intercalate, which is not what we want. That's not what we want. Oh wait, no, that's not right. We want int. Although I can't remember if int comes first or second. So take cycle repeats. Isn't there a function like repeat? Yeah, let's look at data list. That's probably the best one that we want to do. Ah, so replicate. Don't want replicate. Kind of want replicate. There's probably like some monadic one that we can use. So let's do int ma or like fa. See what shapes there are. There has to be like a cycle function that does what I want it to do. Well, cycle's not the right one. But maybe repeat is like infinite. There's no like sized repeat function. I don't really know. Um, I just don't know what this is called. But like obviously you need like to just take excess and do it n times. So we could just do go n excess. Um, so go n excess n less than or equal to 0 is empty list. Like this? Ugh. This is otherwise. I think this is right. I just wrote less than or equal to 0 just to protect it against like mistakes. I guess we can probably load this up and then try to embed something. So we can do cycles to sharp dog. What? Uh, right. Anyway. Oh. That's kind of surprising. Ah, yes. So we only want to do this once, but we're doing it twice. Um, what am I missing here? There we go. I think that's right. Okay, so my intuition for the first one was correct. It's just the second ones were tricky. I wasn't doing them right. Um, like the thing I was doing before was like combining for each iteration, which is actually not correct. I want to duplicate x s every time we have a new n down to 0. Okay, now match is going to be trickier. A lot trickier, I feel like. So, like, there's a split at function. Which feels kind of like what we want. No, it's not. Oh, okay. Um, so we could. Okay, so if we concat replicate, then we get an infinite list, right? And then we could just take n times the length of the list or something. That would be fine too, I guess. Oh, it does? Oh, right. We did look at that, I think. Oh, and then just yeah, you're right. Yeah, that would work. That would be probably better. Um, it's certainly more readable. But we'll just leave the code there. Or uh, yep. Yeah, that makes sense. I like that a lot better. I think it still works. Yeah. That's a lot cleaner. Okay. The issue now will become I don't think there's like an obvious uh unreplicate or split like splitting a list. Like how would you even look this up? Okay, it's gonna be like int list int. That's basically the function we're looking for. Something like this. Oh, okay. So there's a chunks of which is in chunk by, chunk list. So we could use this, which we probably will because then we could just compare them. We'll borrow this. We could write it, but I'm 100% sure that I've written this before. Oh, there's another function here, build. Son of a gun. Okay, let's just go get this, which is split. Or we could get it from extra. I don't know if one of these is considered extra is kind of big, isn't it? Probably relatively small. It's free. It's uploaded recently as well too. So let's just use this. Um, okay. Sure. So import. Wait, what? Control, not control. Data. Where was it? Where was it? Data list. Okay. So What is up with this formatting? Think that formally would do that. I mean, I guess I could just do this as well. Yeah, that's exactly what it does. Okay, so this gives us the chunks. And then all the chunks have to be the same. No, not all the chunks have to be the same. The length needs to be um so first they have to be the right length, and then all the chunks have to be the same. Um there has to be a way to do that, but I don't know what it is. We would just fold over them being equal. So fold map, not fold map. Um are equal. What's the rule here? This will just use fold. R doesn't matter. In this case, right? We need fold L to do infinite things. I don't remember. I feel like I haven't used fold in a really long time. So I think the first thing is we're gonna have an A, a B. Sorry, no, we're gonna have an accumulator and an A. We also need the first chunk, which is the problem. Oh, hey, thank you so much for the Prime sub. I really appreciate that. I think that puts us over. Oh wait, no, our goal is like way higher than we've ever hit. I think we hit it one time, but anyway, I appreciate it either way. It was just sitting there doing nothing. I will use it to buy books. That's what I use that money for, or stuff for the stream. Like I bought the arm and stuff for that. Um, so doesn't really work. I feel like there's something interesting that we can do with applicative, but I don't know. It's not coming to me. I'm very tired at the moment. Okay, so the we also need to fail on like an empty list. So let's just do this. So uh that's step one. Step two is we're gonna no. I don't really want to do another case. Why am I losing my mind? Okay. Um let's do it like this. If this can't possibly be good, but okay. So if we've protected against empty list, so excess is always going to be a thing. So if we get excess empty list, that's going to be false. No. True. Right? We've reached the end. If okay, and then if we get like ys, yy's, we're gonna say zip with equal excess ys all. That's not how zip with works, right? List of A, list of B, list of C. Are they equal? That looks right. What's the issue here? Could have matched expected type bool with actual type. Function. That should be a list. What's all? A2 bool. Isn't there like a all or any? And we they all need to be true. This isn't quite right, but Okay, so I think I'm like going off the rails right now. Yes, I am. Okay, so excess. Um, is this not a thing? Probably isn't, based on what I'm doing here. Okay, done with this guard syntax. Okay, and then so go is supposed to be list of A, list A to bool. Oh, and right, they need to be equatable. Wait, this isn't right either, is it? We get to the end, then it's true. We need scope type variables there. There has to be a better way to do this, but I can't come up with it right now. Okay, so if the thing is empty, or my goodness. Okay, so or nothing. Else, check if all the chunks are equal. Code sucks. That's true. That could be true. Well, it probably is true. Well, I mean, we can just try, right? Import data list split chunks of. Yep. So yeah, null access doesn't do anything. That makes sense actually. But we do want to know not is correct length, right? Because if it's not the right length, just return nothing. There's no reason to do anything else. And then we just go through and check that all the chunks are equal. If they are, then we don't return excess, we return the chunk. So we return the head. The excess doesn't go here. So maybe this is right. I don't know. Okay, so it's supposed to be dog, 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 maybe chunk. Sorry, cycles 3. Import control lens. Oh wow. Okay, I did it. I mean, obviously, we're not doing a ton of really good testing here, but I guess we could probably write a property test for this. Um, like you would just generate an arbitrary string of cycles. Okay, and then it says, can you implement a version of cycles which doesn't depend on a specific iteration count? Um, I suppose you could, but it would be like a search problem, right? You would have to try like a bunch of different chunking techniques, I think. Like you could take the length of the list and break it down into all the factors and then check all the factors, right? I think it would just be a horrible search problem. I certainly wouldn't be able to do it easily. I really want to like think about this next time because I feel like there's got to be a better way to do that. One other possibly interesting thing is that Go has the same type as Elm, but wrapped up in a list. That's true, which means what? How do we? Can we? There might be some like applicative stuff we could do, but like I don't. We can't like lift an entire elem function in, right? That's a problem. But we could just do lm. Okay, what if we did lmxs ys? What does that do? The problem is it's not lm. Although I guess if you just checked if xs is an lm of ys for every combination, that would work. So we could write, I think, oh right. Bool doesn't have a semigroup, right? Because you could be, what is it? Either or all, I guess. All or any. So these all need to be true, which is the same thing. Hopefully, I don't know if LM, I presume that LM short circuits. If it doesn't, then I guess this could potentially be slower, but it's essentially the same function. Good call, by the way. And the tail can't fail because we've already checked that the YS is not empty. So this is probably fine. Does it work is the question. I'm going to guess that it does if I had to look at it. Yeah, seems fine. It's only going to affect the detection or the matching part, not the embedding part. It's probably a little bit nicer. Which now makes me think we can use like interesting. Yeah, I mean that's just that function. So then we would just embed it at that point. LMT. No, T is this. Okay, so LM takes the. So what's the type of this? Should be list of A. Oh, and this is a list of A. So the foldable is list. So for each of these, there you go. Yeah. Yeah, we don't need ln this time, right? Because the types match. It's list of a, list of a. So we can just use equal equal. Look at that. That's way better. Nice. It's funny that sometimes you have to write like all of this to start realizing that it gets easier. Which I don't know, can be a little frustrating. Yeah, yeah. We don't. Yeah, it just works out a little bit, or like it just that's just how the types are. Not much we can do there. And I think you like the equal equal for a list just means that all of its entries are equal, but don't quote me on that. We would have to look at the instance itself, I suppose. But anyway, let's see if it works. The better question. That works. That is fine. Um, ooh, this fails. Okay. So why is it failing? So if all, so we should get derp and derp. Why does the dogs one work? But this one doesn't. Okay, so what's chunks for? Oh, I see what you're doing. Like, is it the character length or something that I'm doing wrong? Uh, which is entirely possible. So let's just like poke around. So split chunks. I would expect that chunks of 2 derp derp should give us chunks of 2. Chunks of 2 is okay. So right, our logic now is broken, I guess. Um we want 2 chunks, not chunks of 2. So 3 worked because it was 3 dogs. Um so chunks of, we need to go look at this splitting code because there's probably a divvy. According to N and M input specifications you provide, each sublist will have N items, and the start of each sublist will be offset by N items from the previous one. Okay, so this divvy is what we want, and it'll be divvy NN, which I think should fix our problem. Divvy. Is that how you spell it? Yes. And then I think chunks of gets replaced by divvy. Okay, but we need to see what it actually does. So divvy, it's NN. So divvy 2 2 of derp derp. Wait, no. How's how's this work? I want 2 lists, not 4. So these are 5 elements. Chop. There has to be a function in here, right? Like just try to make lists of a certain length. Doesn't look right kind of thing. Blanks. Ends with. Okay. So chunks of is not actually what we want. So what we need to do is write the correct make n chunks. Okay. And then once we have that, I think this is right. It's just like that you need this function. Um and so we're basically, and it needs to be perfect. So actually we can even make this a maybe, right? And we can just have a check. Although it doesn't need to be that. I need to sit back down. My knees. What time is it, by the way? I need to be done. Let's see if we can hammer this out real quick. I suppose we could just return an empty list if it doesn't work. And then that way we can just fall through to that issue. And that will be fine. Okay, so where we need to know how many chunks we need. I guess. Well, no, we know how many chunks we need. Um, so we need items per chunk, which is just length, excess, div, and um, and if we take like 11 div 2, we get 5. So we would make right. Okay, so if is okay. Um, so that's the items per chunk. So it will be take Does this work? I have no idea if this is right. No. Because items per chunk can't change. That's the problem. Um, oh, I'm sure there's something better to do here, but like I'm feeling a little fried. Um, this feels like one of those things where you take uh like the head and you mash it together with the tail. Yeah, I mean, this is awful. Like let's be honest. This is not good. Uh I should call these. Like I know this is bad, but my brain isn't coming up with anything better. And I feel like a lot of times I have to write these. So when this thing ends, okay, so go is supposed to be int to list of A to list of A. Um Wait, where? What is that one called? I couldn't find it. That's what I was looking for. We just used it, didn't we? Am I losing my mind? Oh my goodness. All right. Yeah. I'm good at programming, I swear. uh and here we actually don't even care. Uh this totally this is totally good. Totally good. Totally good. Oh my gosh. Go away, please. You can see like I'm falling off a cliff very quickly because I can't even type anymore. Okay, so and then is correct length is still fine, but really it's kind of an unnecessary check. Well, no, it's really not because I think it's fine like this. But the equal equals thing, yeah, this is nice. This is much better. Um, we could also do like, yeah, I think this is probably right. Okay, so derp derp cycles 2. Perfect. And 3 should not work. 1 should not work. Oh, 1 would work for everything, right? Because everything's a cycle with itself. What happens if you do 0? Divide by 0, so we need to double check that. Um, well, really, that can go first, right? Like, there's no. Okay. And then 1 should always work. That would be a good property test, actually. Like, given any string, cycles 1 better be true. And then that works. And then if we derp, sorry, cycles serialize, sorry, cycles 2 or 10. And then me earlier was probably something like that. That was me earlier. Oh, okay. Is it? I guess it really is that much. Yeah, no, thank you a lot. Like, this was really good. I think like working together to get to stuff like this is always really fun. Um, Especially when I do really, really dumb things like write a chunks of function that already exists. Oh, geez. 3D Prima. I'm not sure how to pronounce it. Anyway, thank you so much for the follow. I really appreciate that. Sorry, I missed it. You should have gotten a notification on your screen. But wait, thank you so much for the follow. I really appreciate that. Sorry, I missed it. You should have gotten a notification on your screen, but I don't have my headphones in, so I didn't hear anything. Actually, do I even have? Yeah. So anyway, cool. We did this. We should check our answers. See if there's anything interesting in here. But I think that we have our tail function. Yeah, it's not possible. Oh, we don't have enough information to run this prism in reverse. Yeah, like this is incorrect. Because you can't construct a tail. It doesn't make any sense. You can only construct a list. You can't construct a tail. You could construct a function that takes a tail, but yeah, anyway. So I think this one is probably right. Yeah, he was writing to embed match, but oh, I was too, I guess. So it's totally fine. Um, he's using Prism. Oh, I see. Okay, I'm just misreading. Yeah, same thing. And then let's see if Chris did anything cool. Okay, so embed can cat replicate n. Perfect. So we did the exact same thing. Good call. And then take. What? iteration equals. Okay, so take the iteration, replicate the iteration to infinity, and then check that it's equal to excess. Oh, this is clever. It's not to infinity. Just take the thing off the front, replicate it, and see if they're equal. That's all you have to do. So, yeah, that's pretty clever as well. So you don't even need chunks of here. Chris is a smart guy. So I'm gonna put that in notes. I'll put it right here. So alternatively, that is not how you spell alternatively. I'm writing the right thing, or wrong thing. We could take the cycle from the front of the list and then replicate it and check if they are equal. Sort of similar to like a like it's kind of like a round trip. I wonder if you could implement this. You probably can. Oh, now I want to write this. This. You probably can. Oh, now I want to write this. Oh, no, I can't do this now. Um, to materialize the correct cycle and compare it to the given cycle. That could be fun. I don't know if we can do that. Like the question becomes, can you use this function? I should probably write it like this so it's more clear. Like match isn't being used by embed in theory and vice versa. So can you use embed in match? Probably. I'm actually surprised that it's not using embed here. Like you've already defined embed, so why not just use that? Okay, cool. Um, so yeah, I think that's it for me today. Let me push this up and just quickly say a few words. So if you want to check out this book,